Hey guys, today I want to talk to you about turning H3O concentration, in other words, hydronium concentration, into pH value, and the opposite, going from pH value to H3O concentration. General rule of thumb, if you see a number like this, something weird like that, when you see a negative exponent, that's a giant giveaway that this is a H3O concentration. So weird exponents like to the -8 or to the -11 or to the -4 or what have you, those are H3O concentrations. They're not pHs. pHs are values that go between 0 and 14. You remember that a pH of 7 is neutral, below 7 is acidic, and above 7 is basic. So let's take a look at how to turn this value, which is an H3O concentration, how do we get a pH out of that? And it's very simple. To go from H3O to pH, we hit the negative key, we hit the log key, and I will put in the number that we just had. 6.3 times 10 to the -8. That's it. I hit enter, bam. I have a pH of 7.2. That's as simple as it is. In other words, this particular solution is pretty darn close to neutral. It's just a touch on the basic side. Let's do one more, going from H3O to pH. Let's say we have a H3O concentration of 8.9 times 10 to the minus, let's see, 5. There's my H3O. All we have to do, negative log, and if you don't want to type the number in again, if you have a number and you want to have the calculator recall it, we can hit second function and then the enter key, and I made a mistake. What I meant to say was second function minus key, ants. What that means is take whatever you got as an answer a minute ago and put it in here. So when I hit enter on that, we have a pH of 4.05. We would round that to a pH of 4.1. Great. What about if we want to go from pH to H3O concentration? Well, that's a little bit weirder, but it's not difficult. Say I've got a solution that has a pH of 7.8, and I want to know how much H3O is inside of that solution. Okay, piece of cake. We're going to go 10, then the exponent key, the little hat, and now I'm going to put negative and then the pH. I hit enter. I'm going to get a strange number with a lot of decimals. That's very, very, very common. And you're going to see we have a times 10 to the -8 here. That's a giant giveaway that this is a concentration of H3O. So our solution, pH of 7.8, we get a H3O concentration of 1.6 times 10 to the -8. And that's measured in moles per liter. You may remember moles per liter from Science 20. It's how many moles of a substance there are divided by how many liters. of substance there is. So we'll do one more of these. Let's say we have a solution. Let's get acidic. Let's say we have a pH of 2.3. That's a little bit more acidic than acid rain. Amazingly enough, there are organisms that can survive in this water. I know it's very acidic. This is more acidic than lemon juice. It's about 8 times more acidic than lemon juice. Nevertheless, yeah, life can hang in there. There's organisms that like this. That's actually their favorite pH. So what's the concentration of H3O here? We go 10 exponent negative and then the pH. Boom. So we get 0.005. That would correspond to 5.0 times 10 to the power of minus 3 moles per liter. We could also say 0.005. Nobody is going to freak out if you do that. So there is, in a nutshell, calculating H3O and pH.